Alrighty, welcome to the final video in the exercise 5B series. So this is, now we're working with distance along the same latitude, the same parallel of latitude. Now, we've done the same longitude and the same equator already, and those situations were simple and they were similar to each other in that they were both along great circles of the Earth. So all we had to do there was find the angular distance between those points and multiply by 111.2 kilometers. Now, the difference in this situation is now we're on the same parallel of latitude. And if you remember those diagrams from the start, parallels of latitude are not great circles. They're small circles, and they all vary in their radius. Because when we're at the equator, we're actually really big. We are a great circle. But as we get closer to the poles, the circle that we can draw is a lot smaller. So it has a different radius. Now, that's why this formula here is different. So what this formula says is the distance between those 2 points on the same parallel of latitude is given by the 111.2 from before, but now we have to multiply it by cos theta. The reason we do that is multiplying by cos theta scales that down to the size of the small circle. And there is some complicated proof behind that I won't show you just now, but that's what the cos theta is for. And when we say theta, what we're referring to is how many degrees north or south we are. So what parallel of latitude we're actually on. So when they have the same latitude, that's the number that we're putting into theta. Is that what that latitude is? And then we just multiply by angular distance. And that's the same as before. We can draw a diagram and use that to find the angle between the two places. So it's not too much more complicated, but the reason behind the difference can be complicated. Let's take a look at an example now. So the latitude of Rocky in Queensland and Sao Paulo in Brazil is 23 degrees south. So they're both on the same latitude, parallel of latitude. Well, remember, it's not along a great circle now, so we have to use this different formula. Their longitudes are 151 degrees east and 47 degrees west, respectively. And we want to find the distance between the two cities, flying west, but also flying east. So going both ways around the world. So I would actually recommend using the same circle diagram here to work out the angular distance between the points. But we just need to remember when I draw this circle right now, here's my circle, I haven't drawn a great circle. This is a small circle now. So this circle's radius is not 6,371 kilometers. It's something different. We don't necessarily need to know what that is, but just keep it in mind. So let's label this circle now. Here's 0 degrees. Down here is 180 degrees. And now let's fill our points in. So we'll do Rockhampton first. And Rockhampton's longitude is 151 degrees east. So that means I'll make east clockwise of 0 degrees. So 151 degrees east will bring me down about somewhere here. Okay, it's not perfect, but that's fine. 150 degrees east, and that's Rocky. Now, that's because there's 151 degrees between 0 and the line I've just drawn. Now, Sao Paulo, I'll draw that in, and Sao Paulo has 47 degrees west as its longitude. So west, I have to head anti-clockwise, so to the left from 0 degrees. And it gets me to about here, if I draw that in, 47 degrees. So that point there is 47 degrees west of the prime meridian, and that's Sao Paulo. Okay, so that's my diagram, and I'll use that diagram to find the angular distances in both directions. But no, there's no buts, sorry. So for part A, I want to fly west from Rockhampton to Sao Paulo. So that means I start here at Rocky and I head west, and we've said west is anti-clockwise, so I'm heading in this direction. Okay, so heading in that direction, the angular distance is going to be 151 degrees, so this distance here, plus 47 degrees to get all the way around. And that's going to give me 198 degrees. Okay, so that's the angular distance between those 2 points. So if that's the angle, I can now use the formula to find the real distance. So the distance, I use my formula for when we're in the same latitude, and that's 111.2 cos theta, where theta is the latitude. And sorry, I didn't mean to write an equal sign there. I multiply that by the angular distance. and I need to leave space for B, so I'm going to make that small. Okay, so in this case, that's 111.2 multiplied by cos of theta, and we said that is the latitude, so that's this number here, 23, and we multiply that by the angular distance of 198 that we just calculated. And we'll get our final answer once we type those in, 111.2 times cos 23 multiplied by 198. And the answer is 20,267.31 kilometers. So that's the distance flying east around the globe to get from Rockhampton to Sao Paulo. So now let's do B, where we want to fly, sorry, that was flying west. Now B is flying east. So to fly east, we said east is clockwise on our diagram. So we start here and we fly east. So we're heading around the other way on our circle, okay? So remember there's two ways we can do this. We could find the angle in here and the angle in here, and then we could add those together. Or we could realize the angle we want right now is just 360 degrees minus going the other way around, because together they add up to 360. So going the other way around was 198 degrees. 360 minus 198, I get 162 degrees. Now I just use my formula, same as before. The distance is equal to 111.2 cos theta multiplied by the angular distance. And in this case, that's 111.2 cos of 23 multiplied by the 162 degree angular distance. And let's see what we get. We get 111.2 times cos 23 multiplied by 162. And I get 16,582.34 kilometers. Okay, so that's distance along the same latitude. That's pretty much everything we need to know for this chapter, but it's been a lot of information. So I've made this summary slide here. So let's take a look at it. So the first thing that I think is important for you to know is that coordinates are listed as latitude first and then longitude. It's important to know that order because finding the distance between 2 points on the Earth, you need at least one of those things in common with what we know now. And the process is different depending on which one is in common. Okay? So it matters whether the first numbers between the two coordinates are in common or the second number for each coordinate is in common. Before we look at the differences in calculating those, let's just look at angular distance. So that's the distance in degrees between the 2 points. And what we've seen is for different hemispheres, we add the angles together. And for the same hemisphere, we find the difference between them, okay? Or we can use our circle diagrams, whatever you're more comfortable with. Have a go at both if you'd like to. And then here's essentially the calculation, the formula that we actually use for these calculations. So when the longitudes are the same, that's when we're on a great circle, and we use distance is equal to 111.2 times that angular distance. When latitudes are the same, however, we're on a small circle, and we need to remember that we need to scale our great circle distance down to a small circle by multiplying by cos theta. So 111.2 times cos theta times angular distance. And that's the only difference. So same latitude, you're on a small circle, you use cos theta. Same longitude, you're on a great circle, and it's fine, you just proceed without cos theta. Okay? Thank you guys for getting this far. I know this is a lot of information, and not every exercise would require this many videos or this long amount of time of you watching and listening. I just thought this would be a good test because it's a very complex topic and something that's not similar to anything you've done before. So if you're able to get something out of this, it probably means that you're going to be well suited to getting something out of all of the videos I make next term if we go ahead with the process. So just be assured that not every chapter would take this many videos. Most chapters I could do in 10 minutes, so just one video. Now, please let me know what you thought of this process. Give me some feedback. Be as honest as you can, because this is about your education. My feelings are not going to be hurt. I just want to do the best that I can for you guys. Anyway, thank you for listening and thank you for your patience.